Okay, in this problem we have a stone that is projected at a cliff. It is thrown with an initial velocity of 42 meters per second at an angle of 60 degrees above the horizontal, and it strikes at point A, and at that point the time is 5.5 seconds has passed since the stone was launched. So we are asked to find this little h, the height of the cliff, and then we want to find the speed at which it strikes here. And we also want to find the maximum height, capital H, that it reaches above the ground. So typically we need to prepare, then solve and assess. So that is our recipe. You prepare, you solve, and you assess. And so in this case, we're going to prepare first. For that, we asked to draw a picture. We already have one here. So let's use this one. So this one, we just need to label things. So let's call this 0, this 0.1, and this 0.2. And then let's see what we know and what we need to find. So at 0, we know, well, the time is always equal to 0. The position is always equal to 0. So we are going to choose our coordinate system to be y and x here, and this is our origin there. That is our coordinate system. So the initial velocity v0 we know, and that is 42 meters per second. And then, so therefore we can find v0x, v0y, the initial velocities, the components of the initial velocity. And so, and we know the acceleration, of course, is minus g, gravity all the time. So that's what we know at 0. Let's see at 1. At 1, what do we know? Well, we know that, well, we don't know the time, t1. x1, we don't know that. y1, we also, we don't know that, but that is h, capital H, and that is one thing that we need to find. v1x, we know that because we know that that is v0x, that never changes, and v1y, that we know that is 0 because that is the maximum height. Then we have the point t2. At t2, well, the point 2, the time at point 2, t2 is 5.5 seconds. You're told that right here. And so we know that we don't know x2. We don't know how far it goes. And y2, we don't know that. That is little h, and that is something that we need to find. So again, v2x is equal to v0x, never changes. So that we can find. We know because we know v0 and we know the angle. And v2y, that we don't know, and we need to find that. So now let's start with part 8. So we need to find that h. So for that, we can write that y2 is equal to y0 plus v0y times t0 minus t2 minus 1/2 g t2 minus t0 squared. And this should be, my apologies, this should be t2 minus t0 right here. So now we have that equation, so we can write that y2 minus y0, right? So y2 minus y0, that is actually h. That is what you want to find. And that is equal to v0y, which is v0 sine of theta, which is 60 degrees. and T0 is 0, T2 is 5.5, so I can write this as T2 minus 1/2 G T2 squared, right? So that is, and then I can go ahead and solve for all this. So I get that this is equal to 42 meters per second times the sine of 60 degrees times 5.5 seconds. That is this part here minus 1/2 9.8 meters per second squared times 5.5 seconds, all this squared. So, and if I do this algebra, I'm going to get that this is 51.83 meters, which is roughly 52 meters, and that is my answer. So that is little h. So we've done part A. So let's see, the next part is the speed at A, the speed at 2 there, right? So, well, to find the speed at 2, we need to find both. We need to find v to x and v to y, right? So let's find v to x. We know v to x is equal to v0 cosine of 60 degrees. And so then, so we can find that. So, and v to y, that'll be equal to what? It'll be equal to v0y minus g times t2, right? So applying that equation. So then I can write now that, so v0x, this one here, this is going to give me 42 meters per second times 1/2, which is the cosine of 60 degrees, so that's 21 meters per second. And this one here is going to give me, what is going to give me, let me just write it down here 42 meters per second times the sine of 60 degrees minus 9.8 meters per second squared times 5.5 seconds. So I can do the math here and I get that v to y, and I need more space here, so let's just scroll up. V to y then is equal to minus 17.5 meters per second. So right here at this point, this is the velocity vector. So it has an x component, which is 21 meters per second, which is the same all the way through. And it has a y component, which is negative, right? So this is negative, and it's minus 17.5 meters per second, right? So now we need to find the speed, v2. And so the magnitude of the speed is the square root of v1, v2x squared plus v2y squared. And so I can do that math, and that is going to give me 27.3 meters per second squared. So that is the magnitude of the velocity at 2. The final question in the problem is going up here, is this h, that maximum h. So to solve that question then, to answer that question, we can use this equation. We can say that v2y squared is equal to v0y squared minus 2 times g times h, right? So that is the question that we need to find. Well, this h is delta y, right? Which is, so let me just write this a little. v2y squared is equal to v0y squared minus 2 times g, and then, okay, sorry, I'm missing my, so this should be v1, and this should be v1 here, because I'm looking at at point 0 and 1. So this is y1 minus y0. So this is equal to v0 y squared minus 2 times gh. So then I can rearrange this equation, right? So at that point, this is 0. So then I can write that h, which is y1 minus y0, right? So that is h, y1 minus y0, that is equal to v0 y squared divided by 2g. There are two minus signs that cancel there. So this is equal to v0 sine of theta, this is square, divided by 2 times g. And so this is then 42 meters per second square times the sine square of 60 degrees divided by 2 times 9.8 meters per second square. And now I can solve for h, and h is equal to 67.5 meters. And that's my answer.